look simple, but one wrong decision can double your step. Today, we will learn the smartest way to solve integer replacement using powerful bit trick. Hello everyone, myself Trevor. Welcome back to my channel. So, in this video, we solve question number 397, integer replacement. In the video, we will break down the integer replacement problem in C++ with optimal grid strategy, bit manipulation instead, and step-by-step explanation. So stay till the end for the key decision rule. So here given an positive integer n. So what here if n is even, replace n with n divided by 2. And if n is odd, replace n with either n plus 1 and n minus 1. Return minimal number of operation needed for n to become 1. Here given an example. Here n equal to 8. To minimal step to become 1. Here step is 3 step. Then output is 3. Then another example given n equal to 7. Here to reach become 1. So here take 4 step. Then output is 4. Then another example given, third example, n equal to 4 means output is 2. Means to reach become 1, 2 step are taken. So what's the approach to solve this question? First, we newly approach normal, try both plus 1 and minus 1 recursively, expensive time to slow for large input. So that we take another approach, optimized approach. Here the smart decision rule is if n is even, always divide by 2. If n is odd, so we check if n equal to 3, then go n minus 1. If n modulus 4 equal to 1, then also go n minus 1. If n modulus 4 equal to 3, then go n plus 1. Because this reduces the number of 1 bit faster, fewer and step overall. So now let's start the code. So we take long to avoid overflow. So long num equal to 0. Then we take int steps equal to 0. Here we long not take 0. Here we long we take nth one to avoid overflow. After that we run while loop num. Here num not equal to 1. So here if we check condition, if num modulus 2 equal to 0, then we write n means num divided by equal to 2. Then another condition, official case, else. Here we check if num equal to 3 or num modulus 4 equal to 1, then we num minus equal to 1 else. After that we write else condition, else num plus equal to 1, num plus 1. After that we forward the step plus plus. So here we write step plus plus. After that we return a step. So here return steps. So now we run the code. Here three cases are passed. Now we try run the code. First we take n equal to 8. Then we check n divided by 2 or not. Here n is divided by 2. 2 means 8 divided by 2 equal to 4. Then we check it's even numbers. Then we another divide by 2. It's give 2. Then we check it's even number or odd number. It's now even number. So we divide by 2. Then it answer is odd. We become reach to 1. Here is total 3 steps are taken. First step, then we go with second step, then we go with third step. So here taken 3 steps to reach 1. So our output is 3. Now we submit the code. Here total 47 test cases out of 47 are passed. So in this question, the time complexity is OF log n and the page complexity is OF1. It helps decide whether the increment or decrement reduces further operation faster. So this question always handle n equal to 3 separately. Use long to avoid overflow. Think in binary, not decimal. If you understand this, you will learn a powerful greedy bit manipulation pattern. Like the video, subscribe for more coding tutorial, comment greedy master. Keep coding, keep improving. See you in the next video.